Today we are supposed to discuss the logarithm and inequality parts, and one tutorial you are given including logarithms, inequalities, polynomial functions, and quadratic equations. Right? I am supposed to post this tutorial. Right? It contains 11 pages. Right? Then in the revision class, we are supposed to concentrate doing more sums, right? In this case, your knowledge of theory knowledge is very important. So when we start a new lesson, you have to refer your theory notes and you have to complete the theory notes and be ready for the lesson, because all the theories we can't, of course, discuss from the very beginning in this revision class. Revision means to revise the things. The class we do is a revision. In that case, if we take the time to revise all the theories, dear students, we don't have enough time to cover up during this nearly 11 months we have. So therefore, revision means using your theory knowledge, we use those knowledge to discuss more sums. And here also, I supposed to discuss more sums today. First from the logarithm, secondly, inequalities, right? Yeah, the first thing in the tutorial given, people prove the following laws of logarithms, right? These laws of logarithm was all the laws we have proved under theory, but I am going to prove them at last of this lesson. Okay, I am going to first remind you these laws. First one, we need this change of base formula. That change of base formula says logarithm of b to the base a. You can write introducing another new base. Then it is used like this: log and log we write numerator and denominator. Here we can introduce new base. Suppose the new base is c. New base is c, right? And now this b come in here and this a coming here. This is a change of base formula. On the left hand side, you have base a, but on the right hand side, we have base c, right? Right hand side numerator and denominator we have base is new base is c. This b and this a, this is going to numerator, this is going to denominator, and this is change of base formula. And the next one we need is number 2 is when we have this way, people, logarithm of b to the base a. Here you can very clearly understand when we write log term like this, its denominator is 1. Its denominator is 1. Then you can write this logarithm term at the denominator, taking this log to the denominator. Then these two figures will interchange. 1 over logarithm of a to the base b. This way. This is the next result we need. Right? Okay. Now, next thing is, next results here you have to use these people. Number 3, logarithm of m to the power r to the base a. This r power you can take before, like this. R log is m, this, right? This r you can take before. Conversely, this coefficient of log you can take as the power of m. Okay, right. And most of the time, these are the important ones we use in taking the answers. And the next one you have to remember, when you have logarithm of 1 to any base, it is 0. Logarithm of 1 to any base is 0, right? Okay, and next one, logarithm of a to the base a. When this base and this number being equal, then this answer is 1. This answer is 1, right? And another one we have, people, number 6. It is this a to the power log base is b x. This way. This log x to the base b is the power of this a. Then this number and this base, you can interchange the places. Then this will be written as x to the power log b, this coming here a. These two you can interchange the places, right? Okay, and that the basic so we know this already. Logarithm of mn product to the base a, we write as log m plus log n to the same base a. And the next one is m upon n. This is log am minus log an. And these results, people, very important when we work out the questions, right? Right. Okay. Now another one is here. Now, if we have this people a to the power log a x, like this here we have. Okay, you know this one and this one we can interchange the places. No, this is therefore x to the power log base a, but this is 1. X to the power 1 is x, so therefore here of this the answer is, people, x. That means here number, this number available as the base of log here. Then its answer is this x. Okay, right. Okay, now you have to remember this. In this proof, people, this one and this one and this two with this one, you should know how to prove, right? This two, you should know how to prove. This and this and this. This 5, you should know how to prove, right? And we're supposed to prove that end of the lesson, these 5 rules, right? Now take the questions in the tutorial, right? Tutorial, people, I didn't post it. I didn't post it, but I supposed to post this tutorial tomorrow onwards, right? Okay. Right, now tutorial, take the question number 2 first. Take the tutorial that is in the group. At question number 2, Asking to prove logarithm 81 to the base 27, right? Asking to prove it is equal to 4 by 3. Now we can write this using change of base formula. I write this term, log term, subject to the base 3 by introducing new base 3. And here 81, here 27, right? This answer is 4. You know, logarithm of 81 to the base 3 means the answer of this logarithm of 81 to the base 3 means when you obtain this 81 as a power of 3, what is the required power? It is the answer of this. It is 4. And here, when you take this 27 as a power of 3, the required power is 3. So therefore, the answer comes as 4 by 3. That is just applying the change of base formula, right? Okay, number 2 in it. Second part. Logarithm to the base 2 2/3 plus logarithm to the base 9 by 4. We have to prove this is equal to 0. Right. This one we can do like this. Logarithm to the base 2 2/3 plus this one I am going to write by introducing change of base formula subject to the base 2. Then I can write, I write this first one 9 by 4 as 3 by 2 perfect squared. Then this power you can take before. Logarithm to the base 2 2/3 plus 2 times this one I am going to write logarithm 3 by 2 to the base 4 I am going to write by introducing the base 2. Then it is here 3 by 2, here 4. Right. New base is 2, right? Then this number coming to the numerator, this base coming to the denominator here, subject to the new base. And you know this value is 2, no? This is 2. Logarithm of 4 to the base 2 is 2. This 2 and this 2 you can cancel down, right? This is. Then here we get logarithm 2/3 to the base 2 plus and here logarithm is okay. For this one you can apply the rule we know, this logarithm of mn to the base a is equal to this one we know. Here when we have a sum of two log terms subject to the same base, that you can write like this, same log base and this values we multiply. Then here we have to multiply. The bases are equal and log terms added, then this and this you have to multiply. Then there you get logarithm to the base 2 2/3 multiplied by 3 by 2. This you can cancel down within bracket. We get 1. Then we get log 1 to the base 2. Because you know logarithm of 1 to any base is 0. Logarithm of 1 any base to any base is 0. So therefore, the answer is the left hand side, that is equal to 0, right? This is how we take that answer. Okay, now take its third one. Number 3, it's logarithm to the base 30 to the base 16 32. We have to do as 5 by 4, right? So this also, people, we supposed to write by introducing the change of base formula. We use the base as 2. Right now, this answer, you know, it is 5. No, this is 4. Right. So here, to take the 32, the power we need to take of 2 is 5. It is the answer of this. Here it is. To take the 16, power of 2 we need to take is 4. 5 by 4, I mean like that. Okay. Take question number 3 in it. The tutorial, question number 3. Take question number 3. Asking to prove 1 upon 1 plus log e to the base b plus log c to the base b plus 1 upon 1 plus log a to the base c log b to the base c. Next one, 1 upon 1 plus log b to the base a plus log c to the base c. We have to prove this is equal to 1. Okay, we have to prove this is equal to 1. This one I can write, people, log b to the base b, because the base and this number equal mean this answer is 1, plus log this. And here, this one we can write log cc. This is also 1. Right. And this log a. Okay. Now, here we have the same base b, b, b. And these terms are added. Then these numbers you can multiply. Okay. Log terms are added, subject to the same base b, b, b. So then this answer you can write as logarithm to the base b, multiply these 3, this, and this. It is ABC. Similarly here, the same base, log base c is multiplied by this ABC, plus here log a ABC, right? This way we can write. Now, this each denominator log term, we can take the numerator. When you take like that, these two numbers interchange the positions. So then you can write log b comes as a number, ABC product comes as a base. And here, C, this is ABC. And here, log A, ABC. Now again, in these three log terms, they are added, and the same base ABC product we have. Then we can write this one, multiplying these three numbers, B, C, and A, subject to the ABC product base of log. This is now equal to what, people? You can write log ABC, that BCA again we have to multiply, there we get ABC. Now you can see the base and this number being equal, therefore this answer should be 1. We know when the number and this base are equal, this log value is equal to 1. So this is how we take that answer. This is how we take that answer. Okay, now next one, take question number 4. Take question number 4. Take question number 4. Start. Right. Now, question number 4, part 1. Question number 4, part 1. But it says ABC are the P, Q, and R terms respectively of a geometric progression. Right now, in a geometric progression is a progression like this, no? When I consider 3 as the first term and common ratio as 2, A3, common ratio 2, then the second term 6, 12, then 24, and 48, 96, and so on, we get this. This kind of progression only, people, we call as the geometric progression. Now, its nth term going to be Tn is equal to AR n minus 1. A is the first term, R is the common ratio. For example, here the fourth term can be found subject to these values A3, R2, fourth term means n is 4, then 3. 2 to the power 3, 8 into 3 is 24. This is coming. Right. Now, here we are given ABC. Right, Pth, Qth, and Rth terms respectively of a geometric progression. Okay, so then I am going to consider the first term of this geometric progression as capital A. Let first term be capital A and common ratio be capital R. Okay. Then pth term we write like this. We can write A R P minus 1. But TP, pth term given as A. Therefore, I can write AR P minus A equals simple A. Okay. Similarly, we can write second one, qth term. It is AR Q minus 1. It is given as B. R term AR R minus 1. It is given as people C. right? Take this as number 1, number 2, number 3. Okay. Now asking to prove this. Right. I take log on both sides of number 1, log on both sides of number 1 to any base. Here in the answer, base is not mentioned. Whenever there is no base we consider as usually 10. But in this case, no need to worry about the base of this log. Right. So then we take like this, taking log 1 both sides of number 1. Then we get log a r to the power p minus 1 is equal to log a. Then in between this a and r to the power p minus 1, we have a product. No, when we have a product between these two, I can write this as a sum. Log a plus log r to the power p minus 1 is equal to log a. Right? Now this p minus 1 we can take before of this. Log a plus p minus 1 log r is equal to log a. Now in the answer, people, this log a term has been multiplied by q minus r. To get that, we multiply both sides by q minus r. Multiply by q minus r. Then here we get q minus r times log a plus q minus r times p minus 1 log r equals q minus r log a. Okay, q minus r log a we get. Okay. Now keep this as equation alpha. Now we take second one. In the second one also, I take log both sides. And in the answer, log b is multiplied by r minus p, no? Then we multiply this r minus p, right? Similarly, we can write. Similarly, by 2, right? Directly we can write how, people? This we can write as log a plus, right, log r to the power q minus 1. R to the power q minus 1, no? Right. I'm not going to write this way, step by step. Now here we have a r to the power q minus 1. Then first we take sum of this and this as here. That I am going to write here, r to the power q minus 1. That q minus 1 you can take before. Right? And is equal to log b now, right? Log b now. Now that log b term should be multiplied by, people, r minus p. Then both sides we multiply by r minus p, right? Yeah. In the answer, r minus p times log b we have. Then we multiply both sides by r minus p. This is multiplied by r minus p. R minus p log a, and here r minus p log b. This is beta, right? This same steps, but I wrote without using those steps, right? Straight away I wrote. By 3 you can write. When you take log people, you can write this as log a plus log r to the power r minus 1. This r minus 1 you can take out, right? Log a plus, right? Simple r minus 1 coming before. Log r is equal to log c. Now log c term multiplied by what? Log c term multiplied by p minus q. This is multiplied by p minus q, right? Right? P minus q. Take this as gamma. Right here, writing 1 in this way, taking the result. If we have another 2 similar things, people, no need to write this all steps, right? By using this answer, getting hint by that, you can write the rest too. Now what we do is, people, we add this alpha, beta, and gamma. Alpha plus, beta plus, gamma. All right. Add this alpha, beta, gamma. Add this alpha, beta, gamma. Right. You get this answer. Add this alpha, beta, gamma. Right. Then you get this answer. Alpha plus, beta plus, gamma. Right. Left hand side we have to add, people, this, and this. For them, this log a is common. Take log a out. In within bracket we get q minus r, r minus p, p minus q. Q minus r, r minus p, p minus q. Right. And in here, log r is common for all 3. Take log r out. Once you take log r out, here we have q minus r, p minus 1. And here, r minus p, q minus 1. And here, p minus q, r minus 1. Right? Equals, on the right hand side, people, this q minus r log a plus r minus p log b plus p minus q log c. Right. Now simplify within bracket. Here minus q plus q minus r plus r minus p plus p can be cancelled down. This is 0. Therefore, this whole product is 0. And here log r. Now simplify within this bracket too. Simplify within this bracket too. Here what do you get, people? We get p and q. PQ. We can cancel down with this PQ. Right? And this q into minus 1 minus q. We can cancel down with this plus q. Here we have minus PR. Here we have plus PR. That too you can cancel down. And here we have plus R. Here we have minus R. That too you can cancel down. Right? So then all the terms here cancelled. Now here we have this Rn Q, right? This RQ here, people, minus RQ. That too you can cancel down. And here plus P, here we have minus P. You can cancel down now. Now all the terms within bracket also, within second bracket also cancelled. Then 0 we get. Then this also 0. Then this is 0 plus this into 0 means 0. Left hand side 0 is equal to this. That means, people, this is 0, right? Then you can write the answer like that. Then you can write hence Q minus R log A plus R minus P log B P minus Q log C is equal to 0. This is how we take that. I take question number 4, part 2. Question number 4, part 2, take. So part 2, it's log 2 to the base E times log 625 to the base X equals log 16 to the base 10 log 10 to the base E. Then asking people to show the X as 5. X as 5. Okay. This log term I can take to right hand side denominator like this. Now log 625 to the base 6 equals log 16 to the base 10 log E10 divided by log E2 like this. Okay. Now here we can apply change of base formula. You can remember the change of base formula. Log this one you can write, introduce a new base. Suppose the new base is C, then this number come into numerator, this base come into denominator like this. Now the converse result, when we use log division, we have the same base C we have. Then this one you can write like log. This number come in here, this number come in here. Okay. Then here we can write this one logarithm 16 to the base 10. This is log 10 to the base 2. Okay. This is now log 625 to the base X. Okay. Now this one I can write applying the change of base formula subject to the base 2. Right? This one I can write subject to the base 2. It was log 16 to the base 2 log 10 to the base 2. Applying the change of base formula, write in subject to base 2. And this is log 210. Left hand side we have this, no? Then this 2 you can cancel down here. And this answer is 444. This is log 625 to the base 6. Now you can convert this logarithmic form to index form. 625 we leave in the left hand side, x to the power 4. This gives us 625 is equal to x to the power 4. So then this number should be 5, no? 5 to the power 4 only. 625. So therefore this implies x equals 5. Five to the power 4 only, 625. That's how we take that. And next one. Take question number 5 in it. Question number 5. There you are given under question number 5. Simple A equals log 3 to the base 2. Simple B log 5 to the base 3. Simple C log 2 to the base 7. Show that log 63 to the base 140. Is equal to this 1 plus 2ac divided by 2c plus abc plus 1. This way. Now we start from the right hand side. To the right hand side, these figures we substitute by these. Then we keep simplifying that. Okay. Then we take the left hand side answer. That's the easiest way of getting this answer, right? Okay. Right, now start. Now I am writing the right hand side. 1 plus 2ac divided by 2c plus abc plus 1. 1 plus 2 times a log 3 to the base 2 c log 2 to the base 7 2c log 2 to the base 7 plus abc log 2 log 3 to the base 2 b log 5 to the base 3 c log 2 to the base 7 plus 1. This way we have okay. Now we'll write this way. this 2 I can take as a power of this 3, right? Then that will be 1 plus log, once we take this 2 here, 9 to the base 2. And this log term we write under this, below this, then these two numbers will change. This is log 7 to the base 2. Correct, no? Subject to what formula? You know the formula, this log b to the base a. This is at the moment at the numerator, no? You can take this to denominator. Then numerator 1, these two exchange. Log ab like this. Huh? That way you can write. And next one, these two we can bring here. Log 4 to the base 7. Okay. And then you can take this one below this. Log 3 to the base 2 divided by, once I take this to denominator, these two figures will interchange. Log 7 to the base 2. And this is log 5 to the base 3 plus 1. Okay. Now, I can write people this one by applying the change of base formula. Here 2 and here 2 we have. You can write this one as log 9 to the base 7 by the converse use of the change of base formula. Then here we get 1 plus this one log 9 to the base 7. Okay. This is log 4 to the base 7 plus this one we can write log 3 to the base 7. Into log this 5 to the base 3 plus 1, right? Now, this log term, again I can write taking that to the denominator. Then these two figures will interchange. Okay. And meantime, I write this one as log 7 to the base 7. Okay. Log 7 to the base 7 plus log 9 to the base 7. And here log 4 to the base 7. And this one now log 5 to the base 3 divided by log 7 to the base 3 and plus 1. People, these two you can simplify, same base, log terms added, then multiply this and this. Here we get log 7 base 7, here 63 divided by log 47 plus. How to write this, people? The numerator log 3 base 3, here also base 3. Then we can write this one as log 5 to the base 7. And this 1 also I can write log 7 to the base 7. Now you can write this one log 63 to the base 7, and here log 7, the same base. Then we have multiplied this, and this. Then we get 140. Now you can write this using the change of base formula, log 7, log 7. Then you can write as this log 63 to the base 140, right? Log 63 to the base 140. So this is how we take that task. Right. Take question number 6 in it and start. Take question number 6. Show that log xy squared to the base 9 equals half log x to the base 3 and log y to the base 3. Hence all these simultaneous equations given like that. Right, start. Okay, number 6, it is log base 9 xy squared equals half log x to the base 3 plus log y to the base 3. This is what we have to prove, right? We start from here, people. Log xy squared to the base 9. We write using change of base formula, introducing the base 3. Yeah, then this xy squared come into this numerator, this 9 coming here. This answer is 2. Here between x and y squared we have a product, no? Then this xy squared we can write log 3 x plus log 3 y squared. Now this 2 we can take before, and meantime we can divide by this 2, both this and this. Then we get this is half log x3 plus 2 log y3 divided by 2. And then we get that answer, no? That we get. Okay, now hence all the simultaneous equations, right? Hence all the simultaneous equations. Log here 9 xy squared equals half. Right, and the other one is, right, this one we can write, people, by this now. It sounds to be obtained like this now. Half log x to the base 3 plus log y to the base 3 equals half. This is number 1. The next one is log x3 into log y3 product is equal to -3. is number 2. Right. These are the two equations. Now we have to simultaneously solve. Right. By 2, we subject this log y to the base 3 equals, take this to right hand side denominator, minus 3 divided by log x3 like this. Subject this, taking this to right hand side denominator. This figure now available, people, in number 1. For this place, we put this, substituting in 1. Substituting in 1. What do you get? Half log x to the base 3. Log y3 means this, minus 3 divided by log x to the base 3 equals half. Right. For my convenience of writing, people, I take this, let t equals log x to the base 3. This log x to the base 3 I take as t. Then this will be, this is t divided by 2. Plus and minus minus. 3 divided by t equals half. Okay. Now we multiply both sides by 2t. Multiply both sides by 2t. Once we multiply this by 2t, we get 2 and 2 cancel, t squared come in. Minus 2 and t when you multiply, we get 6. And once we multiply this by 2t, we get only t. Take this side. We get a quadratic equation in t. We get a quadratic equation in t. Then factorize this. The factors are t minus 3 into t minus 2 equals 0. Then equate each factor to 0 and there are 2 answers. T equals 3, t equals 2. Now we have to find this x and y, no? We have to find this x and y. We have to find this x and y. Now, t is this. T equals log x to the base 3, right? First answer, when t is 3, put the 3 here. Log x to the base 3 is equal to 3. Then this x can be subjected, people. Take this base to the right this way. 2 to the power 3. X is 27. That is when t equals 3. Secondly, when t equals 2. Then that is log x to the base 3 is equal to x equals 3 squared. X is 9. Right. But we have to find y also, people. We have to find y also. Right. Now I take this x27. When, all right, we can take this log x3, no, here we have, right. When x equals 27. When x equals 27, Here, log x3 is 3. The relation between y and x is this. Log y to the base 3 is equal to minus 3 upon log x3. Right, when x equals 27, this answer log x3 is 3. Therefore, this is 3. Right, people? Then we get this is the answer minus 1 log y3. Y is 3 to the power minus 1. 2 to the power minus 1 is 1/3. So therefore, first set of solution, therefore x equals 27, y 1/3. One set of solution is that. Second, people, t equals 2. Right, here log y to the base 3 is equal to here minus 3 upon log x3. Log x3 means t. Second t value is 2. This. Then we get y 3 to the power minus 3 by 2. Okay. This one you can write y equals 1 upon 3 to the power 3 by 2. That means, what is this, people? 3 to the power 3 is 27, square root of 27. Square root of 27. Have I made a mistake there? Yeah, here the factorization was wrong. It should be t plus 2, then t equals minus 2, right? So then one answer, when t equals 3 answer is correct, t equals minus 2 answer we have taken. No? Then here we get this say t equals minus 2, this say 1 upon 9. No? X is 1 upon 9, t minus 2. And secondly, we are put here t minus 2. No? T is minus 2 means, right, that is log x by 3 is minus 2. No? And here plus 3 by 2 coming. No? Then this answer is this, correct. 27, square root of 27. Yeah, that's a mistake. Sorry. 3 to the power 3, 27, power half means square root 27. So therefore, next answer is when x equals 1 upon 9, y is root 27. That way, x and y both you have to give the answers, right? Okay. Right, similar questions available in question number 7. Take another one question in number 8. Number 8, take question number 8, second part. Question number 8, part 2. Question number 8, part 2. Take that next question. Use log x to the base 3 plus 2 log 3 to the base 6 minus 3 equals 0. Solve the following equations mean you have to find people x. Right. I write this one log x to the base 3 plus 2 times. This log term I take to denominator. Then this 2 will exchange as 2 divided by log x to the base 3 minus 3 is equal to 0. Now I take let t equals log x to the base 3. This is t, therefore this is also t. Then we get t plus 2 upon t minus 3 equals 0. Multiply this by t. This is t squared plus 2 minus 3t equals 0. Factorize this. T minus 2, t minus 1. Then t equals 2, t equals 1. Then you have to convert this to people x. Right. When t equals 2, when t equals 2, log x to the base 3 is equal to x can be subjected, taking the 3 here, right hand side, this way, x is 9. One answer. When t equals 2 or t equals 1, log x3 equals 1, x equals 3 to the power 1, x equals 3. Right. Right. Question number 8, part 4. As the next. 8 part 4. Logarithm to the base 3, 2 minus 3x is equal to logarithm to the base 9, 6x squared minus 19x plus 2. Right. Try to get this answer. Right now, you can write people this one by using the change of base formula, right? Subject to the base 3. Subject to the base 3, I can write like this. Nine like this, 2 minus 3x. But this answer is people 2. This answer is 2. Right? Log 9 to the base 3 is 2. Now this 2, you can bring left hand side here. That 2 you can bring as the power of this. Then directly I can write that. Log 3, 2 minus 3x squared equals log 3, 6x squared minus 19x plus 2. Okay. Now we remove log from both sides. We remove log from both sides. Removing log base 3 from both sides. We get 2 minus 3x perfect squared is equal to 6x squared minus 19x plus 2. You can't say cancelling log from both sides. That's wrong. Concept is wrong. You can't cancel down log from both sides. Cancellation means we divide. No? Cancellation means we divide. Log by log 3, log base 3, we remove from both sides. Then if you see for that cancelling log 3 both sides, log 3 has no meaning, people. Log 3 means this, no? Log 3 only. This number we don't have there. So therefore, cancellation log 3 from both sides is wrong. We can say removing log to the base 3 from both sides. Right. Then expand this, we get 4 here, minus 12x plus 9x squared equal 6x squared minus 19x plus 2. Right. Take at this side 3x squared and plus 7x and 2. Right now. Here, you can write here the factors, right? Like this. 3x squared plus 6x plus x plus 2 equals 0. Take 3x out here. X plus 2 here, take 1 out. X plus 2 equals 0. Then x plus 2. 3x plus 1. We get x minus 2, x minus 1/3. They are the possible answers, right? But asking here, instead of writing removing log 3 from both sides, what if we put implies sign? Right, I think that is correct, but write in this way, removing log 3 from both sides means convenient, much better, right? This side, this one also, this one implies this, that's also correct. Okay, people, now under this logarithms, in the second page, some questions available. I think you can do them as homework. But this logarithm part, people, we need especially in integration to work out questions we need, and some other lessons for simplifications, this logarithmic relations we need. Okay, right, that is why I did this logarithm at the beginning. Right, so now we come to the next part. It is the inequality part, right? Write the heading as inequality. Inequality is the next part. Inequality. I'll start questions wherever we need important theorems. I'll remind those theorems, right? Otherwise, first finishing all the theories. If you try to do questions, people, we can't finish the lessons quickly. This is how I'm supposed to do the lessons, but in the future, in some lessons, people, for some lessons only, we have discussed the theories from the very beginning. That occasion, I'll explain them from the beginning. But these lessons, when we work out questions, reminding the required theorems or theories, enough. Right now, take question number 10, part 1. Asking, find the range of x of the following inequalities. Find the range of x of the following inequalities. X plus 1, x minus 2, 2x plus 1, less than or equal to 0. Right. What we do is equate each bracket to 0 and find x value. X is minus 1, equating this bracket to 0. Second bracket to 0, x is 2. Third bracket to 0, x is minus half. Right? This is the first stage. Now mark this on the number line. x2 here, x minus half here, x minus 1 here. Here, people, there are two signs. When you take the upper one only, it is less than. And this together, when we consider, it is equal. Since here we have equal sign, all these x values you found, we have to take. Then at those places, circle and color the circle. Circle and color the circle to say that we take those values. Now what we do is this. There are 4 intervals, no? This and this. Right? 4 intervals we have. From any interval you like, take any number you like. So I consider this interval. In this interval only, people, we have 0. We select this 0 because much easy to substitute and simplify. Taking that 0 in this interval, put that 0 for every x and simplify the left hand side, check whether this less than sign, because already equal sign we have considered, that is why we took these values. Consider whether this less than 0 sign become valid. Become valid. Right. Now, when I put 0 there, this first bracket is 1. Here, second bracket is minus 2. Third bracket also 1. So what do you get there? You get minus 2. The answer is minus 2. See whether it is true with this sign. Minus 2 less than 0. Is it true? Yeah, it is true. Minus 2 less than 0 is true. Then that region we accept. That means the region we had 0 is this, no? This region we accept. After finding this way a region that true, accept means true. Then the adjacent region on either side we reject. Then the next adjacent one we accept. Right? Therefore, you have to find at least a region which satisfies this inequality or not. Suppose now this is not satisfying, then the 2 adjacent ones will satisfy this. Therefore, we take them one after other. Satisfy, not, satisfy, not, satisfy, not. That behavior we can see. So therefore, it's important to find out one region. So therefore, here we can write the answer. Therefore, required solution. What? x less than or equal to -1, this region, or x less than or equal to 2, greater than or equal to -half, this way. Okay, the same thing you can write, people. This is the first way of writing that. Second way of writing that is x belongs to the set. This goes to -infinity, right? -infinity up to -1, including -1. So therefore, put here square bracket. Okay. For this word O, union. And in this interval, we can write both included, no? -half, 2. When we need to include them, you have to put the square bracket like this. So therefore, x is an element in this set or this set. This is how we write that. This is how we write that. Right. Either this way or this way, we can use to keep the final answer. And we'll take its third part, question number 10, part 3. It is 12 minus 4x less than x squared. Take its all terms to right hand side. Then here we have 0, x squared plus 4x minus 12. X squared, once we bring this right hand side plus 4x minus 12, we get now greater than 0. So therefore, this greater than 0. X squared plus 4x minus 12 greater than 0. X squared plus 4x minus 12 greater than 0. Now to find the range of this, first factorize this. It is compulsory to have factors, otherwise you can't find the region. Here, x plus 4, x minus 3. Then equate each bracket to 0. Then here we get x equals 3. Here we get x equals minus 4. This is how we get. Now here we don't have equal sign. This time we don't take these values. We circle, but we don't color, right? Circle there. We circle, but we don't color. Now again select. Now there are 3 regions, right? This region, this region, this region. Okay. I select 0. In this interval only 0 lies. Wait. wait. The factors are wrong, people. The factor should be x plus 6, x minus 2, no? Minus 2, 6, minus 2x is 4x, correct. Right. Correct, no? All right. Now, the 2 x values are here 2 and minus 6. Right. Since here we don't have equal sign, we ignore the 2 and 6 both. Right. To ignore, we have to just color, just round circle, but don't color, right? Okay. Now find a region. Right. When you put 0, here 6, here minus 2. 6 into minus 2 is minus 12. In the left hand side, minus 12. Minus 12 greater than 0 is wrong. Here, minus 12 greater than 0 is wrong. Minus 2 greater than 0 is wrong. So therefore, this region we don't accept. This is how we take that. Then we get the answer. X less than minus 6 or greater than 2. Or in another way, you can write x belongs to minus infinity, minus 6, union 2 plus infinity. So this way, normal parenthesis, when we use people, that says these extreme figures we don't take. Like that. That way you can take its answers. Right, we'll take another one. It is this. Suppose we have a fraction like this. X minus 1, x minus 3 divided by x minus 6, x plus 8 greater than or equal to 0. This way we have. The next one. Take the next question this way. Right? In this case, also people, the method as same as before. Equate each bracket to 0. We get x1, x3, x6, x minus 8. Equate in each bracket to 0, find x value. Then mark them on the number line. x1, x3, x6, x minus 8. Here, as a rule, remember, the x value is coming from denominator. 6 and minus 8. Right? When we have this way an inequality, having numerator and denominator, the x values which are coming from denominator, we never take. For instance, if I take this 6, for this 6 minus 6, this bracket 0. If this bracket 0, this product is 0, then the denominator is 0. Denominator 0. When you divide something by 0, the answer is infinity. Infinity means meaningless answer. So therefore, when we have this way a fraction as our inequality, then the x values which are coming from the denominator, we never take. So therefore, 6, we never take. And minus 8. 6 and minus 8 are the ones coming from denominator, we don't take them. Remember that. And now here we have equal sign. Since we have equal sign, definitely the x values coming from numerator we have to take. If we don't have equal sign, then the numerator value also we don't take. Then the numerator value we take when we have equal sign. X equals 1, x equals 3. Color after circling there. X equals 1 and x equals 3. Right. Now, as before, people, select any interval you like, and in that interval, in number you like. I take people 0 is in between minus 8 and 1. So then this interval only 0 lies. I select 0 and I put that 0 for every x and check whether this greater than sign true, because equal sign for this equal sign we have already considered. That is why we took this 1 and 3. And once I put x equals 0 at these places, this is minus 1. Here also minus 3 coming. Here minus 6 coming. Here 8 coming. This is 3. This is minus 48. This plus by minus. This answer is people negative answer. This answer is negative answer, right? Whatever the size of that, it is negative. Negative something greater than 0. Negative something greater than 0 means this is completely wrong. Right? Negative answer coming. It doesn't match with this greater than sign. Negative something greater than 0 is completely wrong. So therefore, the interval we had at 0 does not satisfy this. This does not satisfy. Then the next adjacent one satisfies. Next one does not satisfy. Next one satisfies. And this satisfies. That is how we select. So therefore, we get this interval, this interval, this interval. Right. Then we can write how x less than minus 8 or x greater than or equal to 1, less than or equal to 3, because both of these two we have obtained, taken, included, or x greater than 6. This is the first way of writing. Second way of writing is x belongs to minus infinity minus 8 union, here x included. So then put the square bracket 1, 3. Or union 6 up to infinity. X belongs to this. This is the second way. Whichever the way, one of these two ways you can take. That's how we take that. Right, people, before going to next question, we'll take 15 minutes break. Okay. Right, I continue the class till 10 o'clock today. And the coming weeks, we continue the class till 11:30, right? Okay, now take a 15 minutes break. Now 8 o'clock, come at 8:15, right? So then I supposed to discuss today this inequalities and also. Let's see, right? All right, we'll come to the next definition, people. Definition of modulus of x. Modulus of x means this. Definition of modulus of x. Right. Now, when we take the modulus of a real number like this, minus 12 modulus, its answer is people plus 12. When you take the modulus of plus 12, the same value, right? We can categorize the real numbers into 3 categories: positive numbers, negative numbers, and 0. 0 has no sign. Positive numbers, negative numbers, and 0. When the real number is negative, its modulus can be obtained multiplying that same number by minus sign. Multiply by minus sign. When you multiply minus 12 by minus sign means minus 1, we get plus 12. When the real number is positive, its modulus is the same. When the real number is 0, till the modulus is the same value. The modulus mean, people, the size of a real number. Size only. Size means when I consider the real number line, I can mark 12 here, minus 12 here. Size of this 12 mean, people, the length from 0 to 12. The length from 0 to 12. This length only we define as the size of this 12. Modulus 12 means this length. And modulus means the size of this minus 12 means the length from 0 to minus 12. That means this length. This is the modulus of minus 12. You know, people, a length cannot be negative. Length is always positive. So therefore, when we consider modulus of positive or negative real numbers, final answer is positive. So therefore, remember, when the real number is negative, its modulus can be found multiplying that negative real number by another minus sign. We get positive 12. If the real number is positive, its modulus the same. If the real number is 0, the modulus is the same. So therefore, you can very clearly see if this real number is either positive or 0, then modulus is the same. If the real number is negative only, multiplying it by minus sign, we find the modulus. So therefore, if we consider x as our real number over there, like over there, that 12 minus 12 or 0, then modulus of x is defined to be the same x, right? You know, the same value we get as the modulus when this value is positive or 0. Then modulus of x is equal to same x here if x is greater than 0 or equal to 0. And you know, modulus of this number minus 12, no? If the number here minus, its modulus can be obtained multiplying the same number by another minus sign. So therefore, modulus of x will be equal to negative multiplying this x by minus sign if this x is less than 0, negative. This is how we define, right? This is how we define the modulus of x. Write down definition. Write down the definition. Right. Now, using this as a question, write down, define mod x minus 3. Define mod x minus 3. Right. Then we'll define mod x minus 3. Right. Now assume this x minus 3 as capital X. Then we need what? Modulus of capital X. Right. Okay. Then if this is your x, it is equal to x minus 3. This is your capital X, right? Instead of this x, now we have to take this as capital X, x minus 3, right? Yeah, now if I take this as x, you can think very easily. Here we have mod x, mod capital X. Then it is equal to same capital X if capital X greater than or equal to 0, right? I took this capital X as this x minus 3. So therefore, I can put for this x minus 3. Here also x minus 3. Then take the 3 to right hand side, x greater than or equal to 3, right? This x minus 3 is now capital X. Modulus of capital X will be equal to minus capital X if capital X less than 3. But capital X means x minus 3. Here x minus 3. Bracket x minus 3. Then x minus 3 less than, right, people, x minus 3, sorry, here it was a mistake, x less than 0 X less than 0 should be coming here, no? X less than 0. That means x less than 0 means x is x minus 3, no? X minus 3 less than 0, take this to right hand side. X less than 3, right? So then modulus of x minus 3, we can define like this. If I mark that on the number line, if you mark that on the number line, right, you can mark it like this. 3 here. Here, when x take 3 or more, 3 or more, we can say 3. Here we can color and to the right, x minus 3 mod. Right. Then here, when x is greater than or equal to 3, that means on the right of this 3, mod x minus 3 is x minus 3. This interval, it is x minus 3. What? On the right of 3, mod x minus 3 will be equal to x minus 3. And on the left of 3, that means x less than 3. X less than 3, mod x minus 3 is equal to minus x minus 3. It is minus times x minus 3. This is how we define that. Okay, now we take next one. Take another one more. Question: define this is mod 4 minus 6. 4 minus 6 modulus. 4 minus 6 modulus. 4 minus 6 modulus. Right. Take that. And how to define this now? Modulus of 4 minus 6 will be equal to the same 4 minus 6. If this 4 minus 6 is either greater than 0 or equal to 0. That means taking this x to right hand side, we get what? 4 greater than or equal to x. The modulus of 4 minus 6 will be equal to its negative. That means multiplying this 4 minus 6 by minus sign. Minus times 4 minus 6. If 4 minus 6, this part less than 0, then take this to right hand side. 4 smaller than x. Right. This time when you depict this on the number line, here people we have 4. Modulus of 4 minus 6. Right. Modulus of 4 minus 6 is equal to 4 minus 6. Right. If x less than or equal to 4. Less than or equal to 4. Less than or equal to 4. Equal to 4 is here, less than here. In this side, 4 minus 6 mod. 4 minus 6 mod is equal to 4 minus 6. Minus 6, right? Here, x greater than 4 means on the right of 4. On the right of 4, 4 minus 6 mod is equal to minus 4 minus 6. Minus 4 minus 6. This is how we define that. Okay. Right. Okay, now here remember when x less than or equal to 4. Less than means on left of 4, equal to 4 means taking that 4. Taking this 4 to left. Mod 4 minus x is equal to 4 minus x. Right? Okay. Now some important things you have to understand in this modulus. Right. Now, first thing is this. You can write that as a note. Right. First one, mod x equals a, where a greater than or equal to 0. We'll take only greater than 0, equal 0 case also correct. Now we can take the value of x. Value of x, you can write, people, put plus or minus to right hand side. Okay, this mod we can eliminate, and we can take the answer for x, put in to the right hand side plus or minus. Okay, right. Number 2, mod x equals mod y. There also we can subject this x, eliminate from both sides this modulus signs, and put to one side plus or minus. X equals plus or minus y. Okay. Number 3. When we square mod x, modulus of x we square, then this modulus sign we can ignore, and this only x we can square. This is said as when we square modulus sign. When we square modulus sign, the modulus sign will eliminate, and the number we can square this way. Right? That means, remember, when we square modulus value, we can ignore that modulus sign, and the number inside the modulus sign we can directly square. It is said as when you square, modulus will eliminate. And the number 4 is, people, this. If a greater than b, right? If a greater than b, where a b positive, right? Then a squared greater than b squared. A squared greater than b squared. Right? Both sides should be positive, people. A greater than b, a positive, b positive. Then both sides we can square. When one side is negative, sometimes this is true, sometimes this is not true. So therefore, when we have positive values on both sides of an inequality, then without any trouble, without any issue, we can square both sides. Otherwise, people, you can't square both sides. The reason we can explain very easily like this. Here, 6 greater than minus 12, that's true, no? Here 36, this is 144. This side is not valid, other side becomes valid. One side containing minus sign. Now this way, 6 greater than minus 2, 36, this is 4. Now it is correct. Therefore, if one side contains minus sign, after squaring, the same direction sometimes valid, some occasions the other directions become valid. So therefore, without any issue, we can square both sides of an inequality if both sides numbers are positive. If both sides numbers are positive, right? If both sides numbers are positive, without any issue, we can square both sides, right? These are the things that we have to understand in this lesson to work out the next questions, right? Write down them. Now take your tutorial. Taking your tutorial, question number 11. Take part 2. Question number 11, part 2. Given that mod 2 plus x greater than mod 1 plus 2x. Right, this side positive, this side positive. Right, the reason is, people, you know, after taking modulus, the answer is positive. This is positive, this is also positive. Then what we do is we can square both sides. Square both sides. Square in both sides. Then we get 2 plus x mod perfect squared, we get greater than 1 plus 2x mod perfect squared. You know, when you square modulus sign, we said here, the modulus sign here will eliminate. So therefore, this mod 2 plus x perfect square can be written as 2 plus x perfect squared. 2 plus x perfect squared. Greater than here 1 plus 2x perfect squared. Right. Now don't go to expand, bring that right hand side term to left hand side. 2 plus x perfect squared minus 1 plus 2x perfect squared greater than 0. Right. Take this side. Now we have difference of two squares. Factorize this. 2 plus x minus 1 plus 2x. 2 plus x plus 1 plus 2x. Greater than 0. Now simplify here. 2 minus 1 is 1. X minus 2x is minus x. X and 2x, 3x. 2 plus 1 is 3. Greater than 0. Now you can find the range. Equate each bracket to 0. When you equate this to 0, what do you get? X equals 1, no? When you equate this to 0, x value is 1, I mark that. Here, when you equate this 3x plus 3 is 0, x is minus 1, I mark that here. Here we don't have equal sign, then don't take both. Circle, don't color. Now there are three regions, this region, this region, and this region. Take a value in this region, that is the 0. Put 0 here. 1 minus 0 is, this bracket is 1. When you put here 0, this bracket is 3. This bracket 1, this bracket 3. 1 into 3 is answer 3. 3 greater than 0. It's true. So therefore, this region we accept. The other two regions, therefore, we have reject. Then definitely this region is satisfied. You can check by substituting values taken from this interval and this interval, where here and here. This inequality is not satisfied by those values, right? So therefore, it is sufficient to check only one region, right? So therefore, the answer is what? X less than 1, greater than minus 1. This is how we take that answer, right? We'll take another one more. Question number 11, part 7. Now 11 part 7. X squared greater than modulus 5x plus 6. Right. So we know in order to square both sides, definitely both sides should be positive. Right hand side obviously positive because modulus available. Modulus is always positive. Or 0 is also possible. Right. This is positive now. Now this x squared people, whatever this x after squaring, that the answer we get positive, or the other one is 0. So therefore this side is positive, this side is positive. Therefore the squaring method can then be applied here, right? Squaring both sides. X squared square greater than 5x plus 6 modulus perfect squared. This side, this modulus will eliminate. Here x squared square. Right? Take this side. Okay. Now here we can consider this as difference of two squares. Here this is your a squared minus this is your b. A squared minus b squared. Factors a minus b into a plus b, right? A minus this into a plus b. This way. Then here x squared minus 5x plus 6, you can factorize. What are factors, people? X minus 2, x minus 3, these factors. Here you can factorize x plus 2, x plus 3 greater than 0. Now 4 brackets come in. Equate each bracket 0. Equate each bracket 0 and mark them on the number line and find the range. Right, x equals 2, x equals 3, x equals minus 2, x equals minus 3 we have. People, we don't have equal sign here. That means these values we don't take. We reject them all. Right. Now again, 0 lies between minus 2 and plus 2. Right, factorization is wrong, correct? Right, here x minus 2, here minus 6, no, we have. Therefore, we have to have, it is x, yeah. People, today factorization is, right, no, here factorization earlier it was wrong, now correct. Minus x6 and this x minus 5x come in, minus 6 into 1 is minus 6 come in, right? Now 6 minus 1 come in, no? Minus 2, minus 3 and minus 1 plus 6. These are the x values. Ignore this all. No equal sign, ignore this all. Right. Now, 0 is in between -1 and 6. In this interval, we have 0, right? Put 0 for x. This is -6. This is 1. This is 2. This is 3. I multiply them. We get -36. -36 greater than 0. This is not true. Therefore, the interval 0 lies does not satisfy. This does not satisfy. Then this satisfies. This satisfies. This does not. This satisfies. The answer x greater than -3 or x greater than -2 less than -1 or x greater than 6. This is how we write the terms. Right now, we'll take the next one. This question number 11, part 11. Question number 11, part 11. 7 minus 6 greater than or equal to 2 times mod x squared minus 4. Here also, can we share this? Yeah. Really, here, this 7 minus 6, this is greater than this. Since here we have mod, this is positive. Multiply that by 2, the whole thing is positive. Right? This is positive. Left hand side is greater than this positive value. This left hand side is greater than this right hand side positive value. Right hand side positive, left hand side is bigger than that. So therefore, definitely this should be positive. Otherwise, this inequality does not exist. So therefore, we can say this is positive. Since the left hand side is greater than right hand side, this should be positive, right? And then we can take the first condition here. 7 minus 6 should be positive, right? Why? This is positive. This one bigger than this. If a number is greater than a positive value, that number also positive. Therefore, 7 minus 6 should be positive. Then take this side. 7 greater than x. That means x less than 7. All right. So this is number 1. X should definitely be less than 7, right? x should be less than 7, right? So therefore, whenever we take final answer for x, that x should be in the interval less than 7 interval, right? Now, since this is positive, now we can square both sides, right? Square both sides. Squaring both sides. So 1 minus x of x squared greater than or equal to 4 times. Once you square that, people, the modulus will eliminate, no? X squared minus 4 perfect squared. I take this 4 as 2 squared. Now take this side. So 1 minus x perfect squared minus this whole thing I can write 2 times x squared minus 4 perfect squared greater than or equal to 0. Now factorize this. Take in difference of 2 squares. Thereafter, you can take the range of x. Hurry up there. Take. Right now, here when you factorize this, 1 minus x, a minus b minus 2 times x squared minus 4. Right. Then a plus b. So 1 minus x plus 2 times x squared minus 4 greater than or equal to 0. Now simplify this. Here minus 2x squared minus 6. Here plus 8 plus 7 plus 15. Here 2x squared minus 6. Here minus 8 plus 7 minus 1 greater than or equal to 0. And now factorize this and this. Take the factors and find the range. You can write this one minus 2x squared. This one you can write minus 6x plus 5x plus 15. Here minus 2, no? Minus 2, we can write minus 2x plus 6. Right. Take here minus 2x out. X plus 3 plus 5 out, x plus 3. Two x when you take out, x minus 1 plus 1 when you take x minus 1. Right. Now write that we are here. X plus 3 and minus 2x plus 5. And here x minus 1, 2x plus 1 greater than or equal to 0. Right now? Now mark this on the number line. X is minus 3 by this. Here x 5 by 2. And here x 1 3x minus 1 minus half. Here we have equal sign. These all figures we have to take. Right, all figures we have to take. Right, we know zero lies here in between minus half and 1 is zero lies. Right. Put 0. This is plus. This is plus. This is minus. This is plus. 3 plus brackets. 1 minus bracket. Then the left hand side product is negative. Negative value only come in. That is greater than 0 means wrong. So therefore, this is not satisfied. This is satisfied. This is satisfied. This is not. This is not. Now we get two regions like this between minus 3 minus half and 1 and 5 by 2. But even though this region we get like this, we have to check whether those regions lie in this interval, because this should anyway be true. Otherwise, this given question, this does not exist if this is not valid for the final answer. So therefore, fortunately, these both regions we got the answer lie in the interval x less than 7. So therefore, these intervals we can take, right? So therefore, the required solution, people what? Including x less than or equal to minus half, greater than or equal to minus 3, or x greater than or equal to 1, less than or equal to 5 by 2. This way we take the answer. Right. Okay, right now people, all the questions we can't solve by using square method. Some questions we can't solve using the square method. Right. For some questions we have to use the definition method. Right. Now when I take the question, this question number 12, part 6, take. Question number 12, part 6. Question number 12, part 6. When I take question number 12, part 6, there you are given mod x plus 2 minus mod x plus 4 less than x. Here, we can't straightaway say, since here we have difference, nobody can say this is plus or minus. Right? This, right? And this also, x don't have equal modulus sign. So therefore, this can be plus or minus. So therefore, in this case, we ignore the squaring method because it is not sure the both sides are positive. Even though both sides are positive, we don't use in this case the squaring method. One advantage of using this squaring method is, people, once you square, you know the modulus sign we can eliminate. But in this case, when you square both sides, the left hand side is both modulus signs you can't eliminate, because we have to square this how a minus b square, no? Then square in this, that modulus sign we can eliminate, square in this, that modulus sign we can eliminate, but in the middle we get minus 2 times this multiplied by this. In that product, the modulus signs available, then again we have to use the definition. So therefore, in this case, we use the definition method without using the square method. Square method here we can't use. Right. Now, definition method means we have to define this both x plus 2, x plus 4 modulus. Define that x plus 2 and x plus 4 modulus. Define both x plus 2 and x plus 4 modulus. X plus 2 modulus, people. Right. First equate is 0. When you equal to 0, what is x value? Minus 2. Right. Then x plus 2 mod. Okay. Will be equal to the same x plus 2 on the right of minus 2, including minus 2. On the left of minus 2, it is minus x plus 2. This one equal to 0, x is minus 4. Then x plus 4 modulus on the right of this x plus 4, including that. On the left, it is minus x plus 4. Right? You can use the definition this way: x plus 2 mod. It is equal to same x plus 2 if x plus 2 greater than or equal to 0. Correct? No? Take the right hand side. X greater than or equal to minus 2. This will be equal to minus times x plus 2. Then in the other interval, if x plus 2 less than 0, x less than minus 2. That means the same thing, right? X plus 2 mod is equal to x plus 2 here. X greater than or equal to minus 2, right? Greater than or equal to minus 2 means minus 2 including this direction, right? Including minus 2 and to the right. Similarly here, people, including minus 4 and to the right, what x plus 4 will be equal to this. Right. Now, when you find this kind of question, we have to solve in these 4 intervals. Right. First interval is this. When you move from this side, this is minus infinity, no? From minus infinity up to minus 4, but without minus 4. Why? Minus 4 will be taken when you pass this minus 4 to right. When we go to right hand side of this minus 4, we have to go take in this minus 4. Right? So that is really coming by the definition. X plus 4 modulus, when we define, write in like this, it is equal to x plus 4 if x plus 4 greater than or equal to 0, no? X plus 4 greater than or equal to 0. This means x greater than or equal to minus 4. Here, x greater than minus 4. That means we have to come to the right of minus 4. Then only x will be greater than minus 4. In this case, this says take minus 4 also go to right. Therefore, when you pass this minus 4, and go to right, that location only we have to take minus 4. So therefore, when we discuss this question, we have to come from this end, that is minus infinity end. From minus infinity up to minus 4, but excluding minus 4. Then we go to right, including minus 4 and to the right, including minus 4, up to what? Minus 2. We don't take minus 2 when we go this end. Why? Again, when you pass this minus 2 only, we take minus 2 and go to right. That is by this here, x greater than minus 2. That means on the right of minus 2. There, equal sign also valid. Then when you go to right hand side of minus 2, take in minus 2 also, we have to go to right. So therefore, people, there are 3 regions like this now. First region is what? X less than minus 4. Secondly, What second region? X greater than or equal to -4, but less than -2. Okay. Next region, people. Third region. X greater than or equal to -2. Greater than or equal to -2 up to plus infinity. Yeah, that's the meaning. Right. Then each interval of this tree, we have to solve this question. Right. Then this interval we write mod x plus 2 minus mod x plus 4 less than x, right? Now in this interval mod x plus 2 on the left of -4, on the left of -4, mod x plus 2 means this, no? Right. On the left of -2 all values, on the left of -2 all values, mod x plus 2 take what? Minus x plus 2. Then on the left of -4 also, mod x plus 2 take minus this. Correct, no? We discuss the question in the interval on the left of -4. Right. Now we have to see on the left of -4 means on the left of this, no? This side. On this side, what does this take? This take on the left of -4. On the left of -2, this takes this. Then on the left of -4 also the same thing, take it, no? Then mod x plus 2 will be equal to this. Minus x plus 2. Minus sign. Mod x plus 4. Mod x plus 4, people, here on the left of -4 take this minus x plus 4. Minus sign x plus 4. Less than x. Here remove the bracket, -6 -2. Here minus minus plus. Minus minus plus x -4. This is right here. -6 -2 plus x plus 4. No, people. Minus minus plus x plus 4 less than x. This 2 we can cancel down. Then here we get 2. Correct, no? Here we get x greater than 2. Right? This question we solve in the interval this x less than -4. In this interval only we discuss the question. Then the answer come in x greater than 2. 2 is here, no? For this and this, no common region. We solve the question in this interval, but answer come in x greater than 2. There should be common region to accept an answer here. Since for this and this, no common region in this interval, for this question, no solution. No solution. Understand? Right. Then you can write since x less than -4 and this is x greater than 2. X greater than 2 have no common region. No solution. No solution. Right. Therefore, in this interval, for this question, no solution. Right. Second interval is this. This one. In this interval, again, the same question we have to solve. Mod x plus 2 minus mod x plus 4 less than x. In between these two. Between these two. Mod x plus 2 in that interval minus x plus 2 minus x plus 2. Right. In between this, people, x plus 4 less than x. Give me the bracket here. Minus xc minus xc minus 2x. Minus 2 minus 4 minus 6. Take this side. Minus 6 and here 3x. X greater than minus 2. Then here, this interval, minus 2, minus 4, including minus 4, but excluding minus 2. In this interval only, we solve this question. But this says solution coming x greater than 2. For this interval and this interval, again, no common solution. Right? Then you can write for x less than minus 2 greater than minus 4 and x greater than minus 2 have no common region, no solution. No solution. Then the last one, this. Okay. In this interval, x plus 2 will be equal to x plus 2 minus x plus 4 will be equal to x plus 4 less than x. This 2 you can cancel down. Here we get 2 minus 4 is minus 2. X greater than minus 2. Right. Now see whether we have common region. This interval, including minus 2 and greater than minus 2. In this interval, we solve the question. Then this suggests x should be greater than minus 2. Then you can see for this region and this region, the common region going to be what? Including 2 minus 2 and more says this. This one says excluding minus 2 and more. Then for both the common region is excluding minus 2 and more. So therefore, common region is what? Is x greater than minus 2. So therefore, the required solution is, hence the required solution. Hence the required solution is x greater than minus 2. Now people, from this region and this region, if we had solutions, then to take the final solution, what we do is this solution and this solution and this solution, all three we combine together, not the common region, we take their union, right? We take the common region when we consider the question in this interval. If we get an answer for that too, only we consider common region. If this region, if this interval had an answer by taking the common region, that common region, this common region and this common region, all these three answers we take together, and by adding them only we take the final answer. Adding them only mean, people, we take the union of them. Union means how? Taking all those solutions, we form another new solution. Right? So therefore, in this case, only one we have. Therefore, the required solution is x greater than minus 2. Okay, that's how we take that answer. Okay. People will take another one more in this case. Right, question number 12, part 4 we'll take. Question number 12, part 4. Take question number 12, part 4. It says mod x minus 1 plus mod x plus 1 less than or equal to 3. Take this. Right now here also we have to define this both the x minus 1 mod and x plus 1 mod, right? And this x minus 1 mod, right, its value changes at x equals 1. Once we equate this part within the modulus sign to 0, we get x value as 1. Then on either side of that 1 only, that x minus 1 mod will take different functions. Then on the right hand side, right, of 1 mod x minus 1 take x minus 1, including to the right, and left hand side take it's negative minus x minus 1. Multiply this by minus 5. Mod x plus 1, right? When you equate this to 0, x is minus 1, no? Then minus 1 I mark here. On the left and right of minus 1, mod x plus 1 will take different functions. This one, x plus 1. Here, minus x plus 1. Okay. Including minus 1 to right hand side. So what's the interval? Minus infinity up to minus 1, but excluding minus 1. Including minus 1 up to plus 1, excluding plus 1. And including plus 1 up to infinity. They are the three regions, right? X less than minus 1 region is the first region. Second region, x greater than or equal to minus 1 less than 1. Third region, x greater than or equal to 1. Now each interval, you have to write this inequality. X less than minus 1. On the left hand side of minus 1. On the left of minus 1, this takes this. This also for all values of less than 1. Mod x minus 1 will take this one. Then this mod x minus 1 will be taken on the left of this minus 1 also the same function, because of this takes on the left of 1 for all values of x on the left of 1. This will take this one. Therefore, on the left of minus 1 also, this will take this. And then mod x minus 1 will be equal to minus x minus 1. Plus mod x plus 1. Okay, this one on the left of minus 1, minus x plus 1. Less than or equal to 3. Here we get minus x, minus 2x. Here plus 1, here minus 1. We can cancel down. Less than 3. Then divide by minus 2. People, when you divide by minus 2, remember, when we divide both sides of an inequality by minus value, the inequality direction gets opposite. Right now, you know, when you consider this way, 10 greater than 6, no? Divide by minus 2, we get minus 5. This is minus 3. Now greater than 3, minus 3 is greater than 5. minus 5. So therefore, when we multiply or divide both sides of an inequality by minus value, the direction gets opposite, right? So therefore, when you divide this by minus 2, x greater than or equal to minus 3 by 2 coming. Right now, for this interval and this interval, we have to consider common region. This is minus 1, less than minus 1, but excluding minus 1. Excluding minus 1 to the negative infinity this here. This set of solutions says including minus 3 by 2 to the right. This way. Then for this upper region and the lower region, common region we have to take. Common region. What is the common region? Here people x greater than or equal to minus 3 by 2. Here equal sign also valid. Then this 3 by 2 we have to circle and color. Then the common region going to be what, people? Including minus 3 by 2 up to minus 1, but excluding minus 1, right? X less than minus 1 greater than or equal to minus 3 by 2. Right. Common region means above the line and below the line for two shaded regions, the common. Take it as number 1. In this interval, between minus 1 and plus 1 in this interval here. This takes this takes this, right? Mod x minus 1 will be equal to minus x minus 1. Mod x plus 1 will be equal to x plus 1. Less than or equal to 3. Here we get minus 6, here we get plus 6. We can cancel down. Here 1, here 1, it's 2. 2 less than or equal to 3 only we get, people. No x. But this is true. Not both signs. 3 greater than 2. That's true. So we accept this as true. Since this is true, this is true. Since this is true, people, all this interval we select because of this statement is true. Therefore, solution. All this range we take minus 1 less than or equal to x less than 1. This is number 2. Okay, right. We take this whole thing because this answer is true. 3 greater than 2, it's true. That is why we take to cut all this as a solution. Next one, in this interval, mod x minus 1 plus mod x plus 1 less than or equal to 3. Right. X greater than or equal to 1. Mod x minus 1 is x minus 1. Mod x plus 1 is x plus 1. This you can cancel down. 2x less than or equal to 3. X divide both sides by plus 2, then 3 by 2. I will write the common region. Common region. Here we consider the question, we discuss the question in the interval x1 and greater than 1. This interval. The solution says including 3 by 2 less than 3 by 2. Therefore, the common region going to be common region x less than 3 by 2 less than or equal to, because this equal sign also here, greater than or equal to 1. This is number 3. Now, not like the earlier question, this time 3 solutions we have. Right. So then the final answer is obtained like this. The all x values given by this interval, we put a basket. The all x values available here also we put into basket. This all x value also we put into basket. Now, what are the elements available? Those all elements we take. That means collecting all the x values, we take the final answer. That collection of 3 sets people we do through that union. So therefore, final answer is obtained. How? By collecting 1 union, 2 union, 3. Then the final answer is required answer. Required answer is 1 union, 2 union, 3. 1 union, 2 union, 3 is the required answer. Yeah. So then here, what are the values we take in the real number line? In the real number line, including minus 3 by 2 up to minus 1, but excluding minus 1, all the numbers we take. But here in number 2, x minus 1 again take. Number 1 does not take minus 1, but number 2 take. Then since number 2 takes, we have to include this. Including this up to 1, but number 2 doesn't take 1. Now we have minus 3 by 2 up to 1. Number 1, this value 1 is not taken, but people, number 3 takes that 1. So the number 3 takes that 1. We have to include up to 3 by 2, including 3 by 2. Like this. Now, what are the values? Including minus 3 by 2 up to 3 by 2, including 3 by 2 also. We have the solution, right? Therefore, solution x less than or equal to 3 by 2, greater than or equal to minus 3 by 2. This is how we take the answer. This is how we take. But in some questions, number 12 and 11, now you can do as homework. Do them as homework. Right. I will come to modulus graphs. Write down next heading as modulus graphs. Modulus graphs. Right here, first you have to understand, when we draw a straight line, Right. When you draw a straight line, the standard equation of the straight line is people y equals mx plus c. M is called the gradient. C is the intercept. The gradient defined to be, when we consider this way the line, suppose L, the line makes an angle with the positive x direction in anticlockwise. If this angle is theta, gradient is defined to be tan theta. This is the origin, no. The line cuts the y-axis at this point. To the point, this, from the origin, this height is called as an intercept. Okay, right. Now, when we consider a straight line, for example, y equals 2x minus 3, then the straight line we can very easily draw. Yeah, to draw a straight line, remember people, we need 2 points on the line. To find the 2 points, first we put x equals 0 in it and calculate y. Y is minus 3. That means x equals 0, y minus 3 means that intercept only we get, right? Then the line passes through 0 minus 3 point. To find the second point, put y equals 0 and calculate x. Once you put y 0 here, take this minus 3 to this side. What do you get? 3 divided by 2, x equals 3 by 2. Then the next point is 3 by 2 comma 0. Okay. So when you draw the line now, we can draw the line. First we mark these 2 points on the OXY Cartesian coordinate plane like this. X-axis and y-axis. First point 0 minus 3. 0 minus 3 is here, people. And next one 3 by 2 0. X 3 by 2, y 0 here. Okay. Then the line can be drawn. First of all, after marking this way the 2 points, join them by a line segment. Join them by a line segment. And now produce to both ends like this. This is how we draw that required line. So therefore, remember, to draw a straight line, we should have 2 points. Usually to find out that 2 points, we put x0 and we find y. Secondly, we put y0 and we find x. That is how we find 2 points. But people, finding the 2 points like this not compulsory. Anyway, any 2 points you have to find on the line. That means put in x equals 1, find y value. X equals 2, find value, y value. Or another 2 x values and corresponding y values. That way you can select, you can find 2 points. Then after marking that 2 points on the OXY plane, join that 2 first and produce to both ends. Then we get that line. Okay. Now this is the equation of the line y equals 2x minus 3. Here you must understand, if this angle is alpha, its tan value is the gradient. Since the gradient in this case is 2, gradient mean people, when we subject y plus y we subject, then on the right hand side x coefficient going to be the gradient. The term without involving x, so y is the intercept. So this x coefficient is the gradient. Tan alpha is 2 now. Right. Now you can see when this gradient is negative, the line takes the form this. This alpha will be obtuse angle this way when the gradient is negative, people. Okay, right. First we'll come to this question and then some important properties we have to understand in this case. Thereafter we can do them. Right. Write down this way. Write down the standard equation of the straight line. The standard equation of the straight line is y equals mx plus c. Y equals mx plus c. Write down where m gradient, c intercept. People draw this diagram and write gradient means tan theta. After this, come to this. Draw the line, this. Right, come to the second one. Draw the line, this. Put x equals 0 and find y, y equals 0 and find x. Then mark that 2 points. The 2 points, one is here, other one is here. Right? Then join them. Now we'll draw another one, people. Question. Draw y equals minus 2x minus 3. Draw y equals minus 2x minus 3. Draw this one. Draw y equals minus 2x minus 3. Right. So yeah, also I'm going to put x equals 0. X equals 0 brings what? Y minus 3. Then first point is 0 minus 3. 0 minus 3. 1 point. Second, I put y0. Once I put y0, put here y0, what do you get? 0 equals minus 2x minus 3. Take this side. Plus 2x is minus 3. Plus 2x is minus 3. Then x is minus 3 by 2. Take this 2x this side, minus 3, x is minus 3 by 2. So what is the point? Minus 3 by 2, comma 0. Now, if these 2 points, when we mark on the xy plane, 0 minus 3 is here. 1 point. Other one is minus 3 by 2, 0. Minus 3 by 2 is here. Then join this and this. I drew that on the same YXY plane to comparison purpose to get another important idea. This equation is y equals minus 2x minus 3. Well, now you can see if this angle is alpha, this also alpha. Here 90, no? What is this length? Here to here, 3 by 2. Here, this coordinate is minus 3 by 2. Therefore, what is this length? Also 3 by 2. Length I am talking about. Then we can see these two triangles are congruent triangles. This side is equal to this side. This side is common for both. Here, this angle and this angle being equal. Side angle, side case, the two triangles are congruent. Therefore, this angle is equal to this. It is equal to this. Now, you know, gradient of this is plus 2, gradient of this is minus 2. You can see the two gradients, 2 and minus 2. The two gradient figures, they differ by minus sign. Multiply this by minus sign, we get this. Then people, you can see here, this angle and this angle equal. So this says people, when gradient 5 minus 5, we have for two lines. Then the line that has gradient plus 5, that makes with the positive x-axis an angle anticlockwise. The same angle, the line which has the gradient minus 5 will make on the left hand side of the x-axis. So that in other words, people, if we have gradient 3 and minus 3 people, the two lines will make the angles this and this being same. This is 3, this is minus 3. Understand? So these two angles being equal, right? The gradient with positive value makes with the right hand side of the x-axis the angle. The gradient with negative value makes with the x-axis on the left the same angle. So therefore, if the gradient differ by minus sign, such lines are equiangular to what? X-axis. Okay, that's what you have to understand in this case. And when the gradient is negative, the shape of the line will be like this, so that this angle is acute on the left of x-axis. If the gradient is positive, this angle is acute on the right of x-axis. Right means measure the angle from the right. Left means from the left, the angle we have to measure. That is very important, that idea, to draw the graphs. Okay, right. That you have to understand here. Okay. Right now, next one, count this. The graphs of y equals x and y equals minus x. Oh, right. Draw the graphs of y equals x and minus x. Y equals x graph. People, you know, y equals x graph. You can write this as y equals 1x plus 0. Y equals x, we can write y equals 1x plus 0. Intercept is 0. That means this height is 0. That means the line passes through the origin. Now gradient is 1. M equals 1. Gradient is 1. That means tan theta 1. Tan theta 1. Then theta 45. Theta 45. And then therefore this line passes through the origin, making an angle 45 with the x-axis on the right, because gradient is positive, no? That line is this. This origin, it passes through the origin, making an angle 45 with the x-axis on the right, this way. This is 45. Y equals x line. Y-axis, this is x-axis. Okay. Next one, take y equals minus x. Y equals minus x. Y equals minus x graph. You can write this as minus 1x plus 0. Intercept 0, passing through the origin. Gradient is minus 1. Gradient minus 1 means the same angle 45 should make on the left hand side with the x-axis, this way. This is 45 now. This is y equals minus x plus. Right. Then y equals x, make 45 on the right hand side of x-axis. Y equals minus 6, make the same angle 45 on the left hand side of x-axis. Right. This way. Right. Now we'll see people using this how to draw y equals mod x graph. Right. Now write down the graph of y equals mod x. 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 Yeah. Define people mod x. Mod x. Changes at 0 now. On the right, it is 6. On the left, it is minus 6. Oh, when I define that people, mod x is equal to what? The same x if x greater than or equal to 0. Minus x if x less than 0. Right? Yeah. Then first one. If x less than 0, that means on the left of 0, y equals mod x. We need to draw now. This mod x takes here on the left of 0. This mod x takes on the left of 0 minus 6. Therefore, here we have to put minus 6. Then x less than 0. X less than 0 means on the left of y-axis, no? This is x-axis. This is negative x-axis. X negative means this, no? That means on the left of y-axis. On the left of y-axis is this. X less than 0 means on the left of y-axis. In the left of y-axis, to draw y equals mod x graph, we have to draw y equals minus x. Y equals minus x is this. Its part on the left of y-axis is this part. Then this part only we have to draw. To draw y equals mod x on the negative side of x. Right. Secondly, people, if x greater than or equal to 0, second region, on the right of 0, what is the y equals mod x? Mod x here, on the right of 0, it is equal to x. This is x. That means on the right of 0, that means on the right of y-axis. To draw y equals mod x graph, we have to draw the part of the graph of y equals x. Y equals x graph is this. Its part on the right hand side of y-axis is this part. Therefore, to draw y equals mod x graph on the right of y-axis, we have to draw only this part. Now we can draw the y equals mod x graph. Then y equals mod x graph going to be what, people? It's a V-shaped graph. Y equals mod x graph is this now. This part we need on the right of 0. This part we need on the left of 0, like this. Right. So therefore, this y-axis, the equation of overall graph is y equals mod x. This is 45. This is also 45. If we consider individually this branch only from here to here, its equation is y equals minus x. If we take this part from here to here individually, this is y equals x. So this is the graph of y equals mod x. This is a graph of y equals mod x. Right, people? This is a graph of y equals mod x. Right, sketch the graph. Right now? Right. Right, here we come to the end of today's lesson.